continuation from where we stopped, right? Now, Eigenvectors, and Eigenvalue, right? The idea still remain the same, right? Nothing is changing. Same idea. From the previous class, we solved Eigenvalue and Eigenvector for a 2x2 matrix, right? Now, say you are given this matrix. This is a 3x3 matrix, right? This is a 3x3 matrix. The question says, find the eigenvalue and the eigenvector. Now, because when we did 2x2 matrix, I said first thing first, nothing is changing. There's a relationship between a given matrix, eigenvalue, and eigenvector. And what is this relationship? Do you still remember? The relationship says that a minus lambda I equals what? 0. We did 2x2 matrix, right? He said there's a relationship between a given matrix, say A, eigenvalue, lambda, and what? Eigenvector, B. This is the relationship. Given any question, and the question says that find the eigenvalue and eigenvector. This should be your first task. We call this formula, right? Now, from this formula, what it means is that you are going to solve for A minus lambda I. A minus lambda I, right? This is A, given matrix. This lambda, identity matrix. Meaning, this is a 3x3 matrix. So this is a 3x3 matrix, right? The identity matrix in this case becomes a 3x3 matrix. The identity of a 3x3 matrix. Now recall, what is the identity of a 3x3 matrix? Diagonally, we have what? 1. Meaning 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? Now let's compute the value of this guy. What this means is that the lambda times the identity matrix subtracted from the given matrix. Now from here, lambda multiplied by I. This implies lambda all into bracket 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, what becomes what? Lambda 0, 0, 0, lambda. Now, let's implement this guy. Let's solve for this guy. Meaning that A minus lambda I. What's our A? The given matrix. What is lambda I? This guy. Now, let's solve. We then have that the given matrix. Call the given matrix for me. What do we have? 1, negative 3, 3, 3, negative 5, 3, 6, negative 6, and 4, right? Minus lambda I. This is lambda I. Meaning diagonally, I have what? Negative lambda 0, 0, 0, lambda 0, 0, 0, lambda. Now let's solve. Doing comparison, 1 minus lambda minus 3 minus 0, 3 minus 0. Alright, let's solve. What do you have? A minus lambda I. This becomes what? A minus lambda I. What's our matrix? Our new matrix is what? This guy here. This is your A. This is lambda I, right? Now subtract. What do you have? 1 minus lambda minus 3, 3, 3, negative 5 minus lambda, right? Continue. What do you have? 3, 6, minus 6, 4 minus lambda. Right? Now, this guy here, from this equation 1, this guy, this is it, right? What's the next thing? Equate from equation 1. What it means is that equate this guy to what? 0. This guy here, let's say this is 2, right? 2, we are going to use 2 to get eigenvalues. By the time I know eigenvalue, I'll come back to equation 1 to get eigenvectors. That's the idea. Right? Now, from here, this is equation 2, right? True or false? This is equation 2. This guy here, this is it. True or false? True. Now, from here, what you are going to do, you are going to find the determinant of this matrix. You are going to what? Find the determinant of this matrix. Now, use Cramer's rule. Implement Cramer's rule here. Minus lambda, all into brackets. You know, the idea is that this is your row 1, right? Row 1, column 1, cancel out. Row 1, column 1, cancel out. You are left with this guy. So what are we left with? Minus 5 minus lambda 3 minus 6 4 minus lambda. Now this is just for, I'm using row 1. Then introduce your cofactor, meaning positive, negative, positive. So from here I have invisible plus here. I've implemented this guy. On to the next one. I have negative, all into bracket, negative 3. Okay, if you made use of this place, yeah, it doesn't mean you can use this one, you can use this one. Any rows of column you are using, you still get the same thing. Any rows of column you are using, you still get the same thing. In this case now, I'm using row 1. If you are using row 2 or row 3, you still get the same thing. Or you are using column 1, column 2, column 3, you still get the same thing. Now using row 1, I've made use of this guy, right? 1 minus lambda. The next one is what? Negative 3. Negative, the cofactor, this is it. The magnitude itself, negative 3, right? And the idea is that row 1 cancel out, row 2 cancel out. What are you left with? 3, 6, 4 minus lambda. This guy, this is it, right? From here, this cancel out, column 2 cancel out, row 1 cancel out. You are left with 3, 3, 6, 4 minus lambda. So this is it. Then the last one, we have positive 3, all into bracket, same idea. Column 3 cancel out, row 1 cancel out. What are we left with? 3 minus 5 minus lambda, 6 minus 6, right? Now from here, let's say this is 1, this is 2, and this is 3. You are going to perform determinant to 1, perform your determinant to 2, and perform your determinant to 3. Now let's take it one by one. Let's solve 1, then the next one 2, and lastly 3. Now for the first one, so for the first one, what do you have? Let's do it together. Using the idea of 2 by 2 matrix. The same way we solve 2 by 2 matrix. Let's solve it here too. That will be what? Let's solve for 1 first. What do you have? You know, the idea is that let's say you are given a matrix A, B, C, D. Say this is A. Get determinant A is equals to what? A times D minus what? B times C. That's what you are implementing here. Same idea. So now, what do you have? This becomes what? I'm solving for case 1 first. So I have minus 5 minus lambda, all into bracket, 4 minus lambda, right? Minus 3 times negative 6. Right? Now distribute this guy. This becomes what? Negative 5 times 4. This is minus 20. Negative 5 times negative lambda. That's what? Plus 5 lambda. Then from here, negative lambda times 4. What do you have? Minus 4 lambda. Negative lambda times negative lambda. That becomes what? Positive lambda squared. So from here, we have minus 3 times minus 6 is what? Minus 18. Negative 18. What do you have? Positive 18. Positive 18, right? Meaning you have positive 18. Positive 18. Now, let's bring this guy out. From here, we have negative 20 plus 18. 5 lambda minus 4 lambda. That's what? Plus lambda, right? Plus lambda squared. From here, let's rearrange this guy. Let's do it together, please. What do you have? Negative 20 plus 18 is what? Negative 20 plus 18. Now, minus 2 plus lambda plus lambda squared. Now, this is just the determinant of 1. right? This is the determinant. Now let's introduce this guy, meaning that for case 1, I have 1 minus lambda all into brackets minus 2 plus lambda square. 1 minus lambda, this is it. This determinant, this matrix, this 2 by 2 matrix, we found the determinant, and this is what we got. So we are multiplying it. From here, distribute, multiply all through. This becomes what? 1 all into bracket negative 2 plus lambda square, right? Negative lambda all into bracket negative 2 plus lambda square. Now open up your bracket. This is what? Negative 2 plus lambda square plus 2 lambda minus lambda square minus lambda cube. Observe, lambda square cancel lambda. You are left with what? Minus lambda cube plus 2 lambda plus lambda minus 2. This becomes what? Negative lambda cube plus 3 lambda minus 2. Meaning that for case 1, you perform your matrix using Cramer's rule. You found the determinant multiplied by this guy, and this is what you got. Nothing is changing. Apply the same idea to case 2 and lastly case 3. Now for case 2, right? For case 2, this is my matrix. This is the representation of my matrix. Now let's find the determinant. The determinant of this guy becomes what? That will be what? 3 all into bracket 4 minus lambda negative 3 times 6, right? Not forgetting that you have what? Positive 3. Negative times negative 3 will give you what? Positive 3. Now open up your bracket. This is 12 minus 3 lambda minus what? 18, right? This becomes 3 all into bracket negative 3 lambda. 12 minus 18 is what? 12 minus 18. That's negative 6. Distribute this. 3 times negative 3 lambda. That, what do you have? Negative 9 lambda. Then minus what? 18. Minus 18. Meaning that for case 2, this is what you got. Now, lastly, let's solve case 3. For my case 3, let's find the determinant. The determinant is what?
Okay, 3.
The determinant, 3 multiplied by negative 6, right? Minus all into bracket minus 5 minus lambda times 6, right? Now, let's solve this. This is what? Negative 18. Negative all into bracket. Negative 5 times 6 is what? Negative 30, right? Negative lambda times 6. Negative 6 lambda. This becomes negative 18 plus 30 plus 6 lambda. Not forgetting that you have what? What value here? Plus 3. Now, open up. This becomes what? We have 3 all into bracket. Negative 18 plus 30. That's what? Negative 18 plus 30, that's 12. 12 plus 6 lambda. This is equals to 3 times 12. That's what? 36, right? 36 plus 3 times 6 lambda. That's 18 lambda. This is what? 18 lambda. Meaning for case 1, we've gotten our answer. For case 2, we've gotten our answer, right? Now, lastly, for case 3, we've also gotten our answer. What it means is that combine everything together. Now, do your combination is either you end up getting a quadratic equation or a polynomial equation. Then from there, you solve the root of the equation. If it is quadratic equation, solve the root of the equation. You obtain your eigenvalues. If it is polynomial, solve the root of the equation, you also obtain your what? Eigenvalues. Now let's do it together. What do you have? For case 1, what's our answer?
For case 1.
Minus lambda cube plus 3 lambda minus 2. That's what. This is for case 1, right? Plus case 2.
Case 2 minus 9 lambda.
Case 2 minus 9 lambda minus 18. Then for case 3, we got this right, meaning plus 36 plus 18 lambda. From here, what do you have? Negative lambda cube plus 3 lambda minus 2 minus 9 lambda minus 18 plus 36 plus 18 lambda. Now let's group this together. All the one for lambda, bring it together. All the one for constant value, bring it together. Right? Now from here, we then have negative lambda cube plus 3 lambda minus 3 lambda minus 9 lambda plus 18 lambda, right? Minus 2 minus 18 plus 36. So from here, what do you have? This is negative lambda cube 3 minus 9 plus 12. That was minus 6 plus 18. Minus 6 plus 18, that's what? That's 12. Plus 12 lambda minus 2 minus 18 plus 36. That's 16, right? That's plus 16 equals to 0. Meaning we got this equation, right? So what type of equation is this? Identify. Is this a quadratic equation or a polynomial equation? This is a polynomial equation because the leading coefficient here, it is starting from cube. Polynomial, it is starting from cube. And even we have the leading coefficient to be squared, that becomes quadratic. But in this case, we are having cube, meaning polynomial. Right? Now, from here, using this polynomial, you'll be able to get eigenvalue. Initially, question given, find what? Eigenvalue and eigenvector. Now, up to this level, you've gotten an equation, and this equation is a polynomial equation, right? Now, solving the root of this equation, you get your eigenvalues. Solving the root of this equation, you get your eigenvalue. But the idea is that, in this case, check. Can we do any possible factorization? No. Factorization cannot work here, right? Meaning, I would advise, do log division methods. Do what? Log division method. The idea of log division method is that you are going to do trial and error. Now, you are going to assume, let's say that given this root of this equation, let's say the first assumption is that from here we have this guy. We want to solve the root of this equation, right? To solve the root of this equation, you are using log division method. You are using what? Log division method. And the idea behind log division method is that you need your dividend. You need your what? Dividend. Let's take this to polynomial. Let's say you are given a function f of x. Let's say this f of x is a polynomial. This f of x is equals to what? Is equals to divisor times what? Quotient times quotient plus remainder, right? From polynomial, let's say this is a given polynomial f of x, meaning f of x is equals to your divisor multiplied by your quotient plus remainder. Now, relating this guy to log division method, what you need is that from here, this guy, this is your polynomial f of x, this is your quotient, This is your quotient. This is your divisor. And your answer is your remainder. Your answer is your what? Remainder, right? Your answer is your remainder. Now, from here, what it means is that we don't know the divisor. Do we know the divisor? What I mean by divisor is that, do we know any root of this equation? You know, obviously, I'm going to get 3 roots of this equation. So we don't know the divisor. We must know a divisor. By the time we know a divisor, we reduce this number to a quadratic equation. By quadratic equation, you solve, you get the remaining 2 roots. Now, how it works is that we are going to substitute. Your first substitution, let's say x, let's say lambda. Your first substitution might be lambda is equals to plus or minus 1. When lambda is equals to plus or minus 1, when lambda is equals to plus or minus 2, or when lambda is equals to plus or minus 3. What this means is that this interpretation, we are saying that by the time we substitute lambda to be 1 into this equation and you get 0, meaning 1 is a root of this equation. I get what I'm saying? From what we've interpreted here, from this guy here, what it means is that we are doing trial and error. By trial and error, we are trying to get our divisor, right? And after the first trial and error, let's say lambda is equals to plus or minus 1. Meaning, when lambda is equals to 1, if I substitute it in this polynomial equation, I must get 0. That is, the left-hand side must be equals to the right-hand side. If I'm not getting 0, it means x equals to 1 is not a factor or is not a root of this equation. Now, next up, substitute x minus 1. If I'm substituting x minus 1 into this polynomial, at the end of the day, I must get 0, meaning my left-hand side is equals to what? Right-hand side. If negative 1 is not giving me 0, it implies that negative 1 is not a root of this equation. Move on. Try positive 2. By the time we try positive 2, if you get 0, meaning lambda equals to 2 is a factor of this what? Equation. Now, let's try positive 2. Let's try positive 2 and see, probably you get it. Lambda, let's substitute lambda is equals to positive 2. Meaning we are substituting positive 2 into this equation. So that becomes what? Negative 2 cubed plus 12 open bracket 2 plus 16 equals to 0. This is what? Minus 8 plus 24 plus 16 equals 0. Let's solve our left hand side. What do you have? This is what? Negative 8 plus 24. That's 16. Right? Meaning 16 plus 16. What do we have? 32. Right? And this is 32 is not equals to 0. Meaning when x is equals to 2 is not a factor. Now when lambda equals to 2 is not a factor. Now let's use when lambda is equals to negative 2. Using lambda is equals to negative 2. Let's do this together. What do we have?
Minus.
That would what? Minus all into bracket minus 2 cubed plus 12 all into bracket minus 2 plus 16 is equals to 0. This is what? Plus 8 minus 24 plus 16 is equals to 0. This is what? Negative 16 plus 16 is equals to 0. That is 0 is equals to 0. Therefore, when lambda is equals to negative 2 is a root of this equation. You say it is a root, or you say it is a factor of this equation. Now, this same guy, you can write it as what? X plus 2 is equals to 0. Call this 1, call this 2. You can write 1 as 2. True or false? True. This one, we already know that when lambda is equals to negative 2 is a root of this equation. Now, what we actually need, we want to use the log division method. We can't make use of it. We can't make use of it directly like this. So we are now rewriting 1 to be 2. I'm now asking that, is it correct? It is correct. You can now bring this negative 2 to the left hand side. It becomes what? Lambda positive 2 is equal to 0. Meaning, to solve the other factor of this equation, what are you going to do? Use long division. Use long division. So this becomes the division, the divisor in this case. Now, using long division,